Hey what's guys, welcome back to the channel. On today's episode, we thought we'd go take a look at a Victron system. The more I use this system, the better and capable I think it really is. Even though right now the craze on the internet, or at least in the industry, I think right now seems to be about the all-in-one inverters or the hybrid inverters, whatever you want to call them, you know, the inverters that have everything you need in one system. But I do believe there is a place for Victron modular type systems, right? Not just the type of system, but also the capabilities and components of it, right? So the more I use it, the more I want to keep using it, okay? There's something that just kind of sticks around. A lot of people will say it just works, right? And it really does just work, okay? So we're going to go over this Victron system, which is the MultiPlus-II 48 volt 3000 VA system, also with this Cerbo GX, which is also connected to this EG4 Indoor wall mount battery. And I do believe this inverter with these wall mount batteries are probably the best combination, especially if you plan on expanding. As you can see here, it's a really good combination because of all the pros and cons with just the battery system itself. So we are not gonna go over all the capabilities of the MultiPlus-II because that would probably take 3 to 5 hours, but we will cover the basics and the core things you really need to know about this system in case you were interested in a Victron system. And if people are saying, well, why would you get a Victron versus all this other stuff? Well, we're going to talk about that. So if you're interested in it, stick with us. All right, so first let's talk about this inverter. And I will say this is a MultiPlus-II. They do have a MultiPlus-I. And then this inverter is offered in a 12 volt system, which means the battery feed in, right? 12 volt system, 24 volt system, and also the 48 volt system. This inverter is also offered in lower and higher capacities. I believe they have a 2000 VA capacity, a 5000, and maybe even a 10,000. And this 35 amp rating here is really more of the charging or feed through capability, okay? So because you can't connect to the grid, it can do a lot of different things, and you can also feed the power from the grid or generator, whatever, to the AC output source. So let's talk a little bit about the basic capabilities of this inverter, right? So the feed through current maximum is somewhere around 32 to 35. The voltage range of the 48 volt system is somewhere between 38 to 66 volts, okay? So it doesn't have to be exactly 48, but somewhere in there is where you want to be, which 48 is the sweet spot. But like I said, that's what this is. The output voltage of this inverter is 120 volts, right? It is a single phase low frequency transformer based inverter. And if we didn't talk about this earlier, let's talk about the 3000 VA here real quick. So that is apparent power, and depending on what kind of machinery or whatever you're using to power this thing, there is a conversation to be had about apparent power versus real power. Like real power, a lot of people can talk about watts, but apparent power is in VA, right? There's things that consume apparent power, but in most of the US, not a lot of the consumer electronics and houses or whatnot have to worry about apparent power. But generally, apparent power is in VA, and if you've been buying, you know, UPSs and stuff like that, you know, most of the UPSs are in VA ratings, right? But apparent power is in watts, okay? So if you want to kind of get an idea of how to convert between the two, you want to get the apparent power, then multiply it times the power factor to get the real power. And that's generally how most people or the industry kind of accepts to do it. So, you know, a 3000 VA system times, let's just say, a power factor of 0.7, right? Would be somewhere around your real power, which is, I don't know what that is, like 2400 watts or something like that, right? So if your power factor is 8, then, you know, times 3000.8, right? That's how you would get watts. But let's talk about that, right? So the continuous power that this inverter is rated for at 25 degrees Celsius, which is about 77 degrees Fahrenheit, which is probably most normal people's operating environment, it's going to be 2400 watts. That's continuous power. But if you're in a little bit warmer, 104 degrees Fahrenheit, which is about 40 degrees Celsius, it's going to be about 2200 watts. And then if you're for some reason living in a desert and it's 150 degrees outside Fahrenheit, which is about 65-ish degrees Celsius, it's going to be somewhere around 1700 watts of continuous power. And remember, this is continuous power. Because it is a transformer-based low-frequency inverter, it can do a lot of surge. And I think the maximum peak surge is somewhere around like 5,000 watts or so. But, you know, you only really have to worry about that when you're powering on like big electronics or big equipment and stuff like that, right? So there is other things to be had in here with the Victron software and all the stuff they have going on. You know, you can get better efficiency, but I believe the maximum efficiency for this inverter is somewhere rated around 95%. This is a charger, right? So when it's plugged in to a power source, whether it's grid or generator or whatever, it can charge the batteries. And this is designed to charge 48-volt batteries, and right now it's not plugged in, but if it was, it would be either, you know, light would be on and then it would be telling you where it is in the charging cycle of that, right? The other thing that you won't see right now, but we'll show you later, is that this has an AC1 output and an AC2 output. When you're plugged into the grid, the inverter will actually feed AC1 and AC2, and then for whatever reason, if the power goes out, only AC1 will continuously be on, right? So it's almost like a UPS type system where the switchover is instantaneous. I don't think I've seen any inverter that's faster than this, but one of the reasons why we're looking at this is to kind of replace those UPS systems, because, you know, every like year or two you're gonna have to replace those batteries, and that just gets annoying. So it's better to get something like this where the switchover is almost super fast, that, you know, no electronics are really gonna be affected. There's AC1 and AC2, and then AC1 will always stay on, assuming you have enough battery capacity, and AC2 will just cut off, okay? That's one of the other more advanced features of this. There are a ton of advanced features of this that, you know, we're probably not gonna get into, but like I said, covered the basic advanced features of it. But as you see on here, this is really only an inverter and charger. It does not have a solar controller or charge controller built into it. It also doesn't have like a control system, LED or LCD built into it. This is really just serving two things. This right here is a Cerbo GX. This is really what you call like the brains of the operation. This runs a operating system or software that's built into here, but I will state that you can download the operating system by itself and run it on your own machine or Raspberry Pi or whatever you want to, but I think it's actually best to run it on here because all the ports and everything are properly configured. You don't have to do any, you know, messing around. But, you know, if it's a little bit priced out of your range, you know, I understand that, but I will say there's a huge benefit to just getting the actual device and just ease of use and, you know, all that stuff, right? This has capability to connect to Bluetooth, and you can run an access point. Right now, my Bluetooth is not connected, and if you do connect it to the internet, this can connect to Wi-Fi. It can log, pretty much send the data to the VRM console, which is kind of like the EG4 monitor console that kind of tells you all the information about your system. So you can connect this to Wi-Fi itself, or you can connect it to an Ethernet plug, as you see here. I'm using Wi-Fi, but, you know, let's get into it, okay? So it's got USB ports up here, as you can see. One of this USB ports is plugged into this HDMI cable, which is actually powering the Victron Energy screen that you can buy separately with this, and that, you know, is also a little bit pricey, but it is really worth to have, especially because it's a touch screen, right? And you can configure settings back and forth, okay? There is a set of ports back here that look like RJ45 ports, which are actually VE CAN, Victron Energy CAN bus, and there's another set of RJ45 ports back here, which are VE bus, Victron Energy bus. They're different protocols. I just want to point that out. And then there is another protocol system back here called VE Direct, right? And those are really more of just direct plugs, and those are like, you know, just small DC plugs. There is another port back here we kind of skipped over, which is BMS CAN. That's what this blue cable is connected to, and we'll talk about that a little bit in a second. But this blue cable, I had to custom make this cable. It took me a while to figure out how to actually get it to work. But this blue cable is connected to the EG4 Indoor Battery with BMS communications, and everything works properly. So if you're wondering, can you use the EG4 batteries with the Cerbo GX? The answer is yes, but you have to be using LL or the Power Pro batteries, or the Indoor Power Pro, whatever you want to call it, right? So that does work. There's other ports on here, you know, like tank sensors, and when you buy it, it comes with all the plugs you need to kind of make like the dry contact type system work. There is a slot for micro SD in case you wanted to log data on micro SD and then upload it. For some reason you didn't have internet connectivity or something like that. Speaking of that, you can buy like an LTE dongle type thing that you can use to connect this in case you wanted to transmit you know, from, let's say, the boondocks or in the middle of nowhere to some LTE signal that you could probably get. There's also relays you could use for generators to connect generators to power on. And there's a really nice feature you can hit on this touchscreen to power on the generator, assuming your generator has a dry contact capability. And this feeds in from a power source. So this right now is connected to a battery. It can feed in from a power source, I believe, anywhere between like 8 to 70 volts DC. So any type of system that you're using your off-grid type system with will need to power the system. It cannot be powered by any Ethernet cable like PoE. I did try to find some way to get that to work, and that does not work. You have to feed it power directly. Speaking of that, this white cable back here, which is plugged into VE bus, is plugged into the inverter, and we will take a look at that. All right, so we took the cover off, and to take it off, there's a screw right here, Phillips head screw here and here. You take those two off, the cover slides right off pretty easy. These three connectors right here are your AC1 out. These three connectors right here are your AC2 out. And these three are the AC in. There's clamps for each of those. There's also a little grommet for each of those. This right here is your grounding screw. You do want to make sure you ground it to protect the earth or whatever else is metal in your system. For instance, this case, this ground wire is connected to the battery because the battery in the conduit box is all metal. This right here is your positive battery cable. This right here is your negative battery cable. In here, you'll see mine's a little bit complicated. I do not recommend you do this. This right here is a power cable for the Cerbo GX, and this is the negative battery cable for the Cerbo GX. The reason it kind of looks like this and not the standard cable it comes with, which is this, right? Is that I've added another layer of insulation, a wire insulation. Then I wrap that layer in electrical cord or tape because of the grommets that were here, okay? It does include grommets for the battery cables here, and you don't need battery cables this thick. This is 2/0 cable, which is way overkill for this battery connection. But these are the cables that came with the EG4 Indoor Battery, and they do fit here. And the reason I'm using these cables is mainly because I do think that that battery is, again, the best battery probably for the system, especially if you add 2 or 3 or something inverters, mainly because it comes with these and it fits perfectly with the quick connect, all kinds of fun stuff, okay? I do not have the grommets on here because 2/0 cable is way too big for these grommets. I'm sure you could probably somehow make it fit. Even if you did make it fit, the terminals here that you were passing through would have been too big. So if you are going to try to use this, put the grommets on first before crimping the cables, which I obviously didn't do that. I have a lot of splicing tape wrapped around here and also a little bit extra here to prevent any chafing or any possible contact between the cable inside and the case. This white cable, as we talked about earlier, is the VE bus port. I'll take it off. You can see some of the other ports on here. If you look here, there's a bunch of relays you can use. There's a jumper you can use, VE bus, a current sensor, 3.5 millimeter port that you can use for current sensors here. There's other dry contacts here that you can use for all kinds of fun stuff. White Ethernet cord. It's a standard Ethernet RJ45 cable. You plug in the VE bus and you can also plug into the Cerbo GX, and it sets up communication between this inverter and the Cerbo GX. I'm pretty much using here 12 gauge Romex. And the 12 gauge Romex is solid, so when you put it into these terminals here, you don't really need a ferro. But if you're using thin stranded wire, you do need to. But if you're using something like, let's say, 6 gauge, it's stranded, but it's like thick core stranded, so you probably don't need to put a ferro on here. But I will say this connection method they have here is probably, I would say, the worst part of this entire system, if there was anything to complain about. You know, I kind of understand why they wanted to do that, make it a little bit easier. You didn't have to crimp stuff or, you know, all kinds of other stuff. But the way that the crimp or the connection is made here is that there is a little port. You see 2 ports here. There's a port where the wire goes in and a rectangular port right above that. You have to use either a flathead screwdriver, or in my case, I also used a framing nail to press in that port to relieve the pressure on the spring that clamps down on the cable. So this is a friction type fit clamping system. It's not like you screw and it clamps together. There's a spring-loaded clamp in here and it clamps down on the wire, right? And even on these. So if you pull it, do a solid pull test, and it's not going to go anywhere. But it is a pain to work with when you're removing stuff. If you're using Romex solid core cable, it's not that bad because all you need to do is insert it, and you're probably not going to take it off depending on whatever you're doing. But there is warnings written everywhere, especially here, right? And on the cover and on the label that says you need to insert it a minimum of 0.7. And you need to strip maybe about a whole inch of the wire goes in there, but the core of the wire, the conductor, needs to be stripped to about 0.7. Okay, so there's been, I want to say, probably issues and maybe even possible fires due to bad connections made here by people. So I will highly emphasize when you are using this, make sure you make a good solid connection. Somewhere close to about 1/4 of an inch of exposed conductor needs to be fully inserted into this connection mechanism. Cannot emphasize that enough. It's much easier to do when you're using solid core wire, which is why I pretty much set this up with Romex here. The second thing I'll note on here is that this wire here is severely undersized, but this is the wire that I just found right here on hand. I crimped ferrules on there and put it in here. But this, I believe, is like a 16 or maybe 14 gauge wire. And you put ferrules on here because this is pretty thin stranded, and you put it into the AC in, and there's a cord so you can plug it into the wall in case you need to, right? But even though it is undersized, you can go into the settings and set the maximum AC in current. So if you are going to undersize the wire, make sure you properly set the settings, or you're going to pretty much overload the wire and have all kinds of issues. There's a bunch of ventilation holes here. You can see on this side and this side. The switch for turning the inverter on is here. If you pull it towards you, which is option number 1 or one line, then that means it's on full mode, inverter mode, charger mode, whatever. If you flip it towards the back, which is 2 stripes or 2 lines, you're operating in charger mode only. So, inverter function is not going to work or any of that stuff. The other thing to point out on here is that the DC input, which is this battery system here, is isolated from the AC output. You cannot say that on all inverters, but on this inverter, it'll even tell you here, right? And because also a transformer-based inverter, and you can look at the design, it is isolated. So that is a huge plus. So this right here is the conduit box you just saw, and then the conduit box is part of this EG4 battery, or you buy it separately technically, but you can buy it as a kit. And it has this metal conduit box attached to the battery using 4 screws. When you buy the battery, it does come with these 2-aught cables using these Amphenol style connectors. They're actually Dexon connectors, but people just refer to them as Amphenol style, even though the Amphenol is the brand, but it's a quick connect, right? So you take the cable, you plug it in there, press it down, and it's solid and good to go. It's rated for, the current that it can handle. It comes with 2 of these. We're using 1 set right now for this inverter. The future plans is to, expand the system and use the bus bars that are on this battery to expand it, right? So this battery, the indoor battery, comes with the built-in 4 connectors, which is the bus bar internally on here. So expanding it or adding more inverters actually just makes it super simple. So negative connected, positive connected. On this door here, you'll see this green wire, which is for ground. There is a grounding screw in there. This copper cable, which is undersized, but we'll have to fix that later, is connecting the metal parts of this battery, this conduit box, to the metal part of the inverter, as you saw up there on that grounding plug. You see here, this is the wire for the Cerbo GX, which I kind of have just powered through the battery terminals you just saw earlier. White wire goes to the inverter, and this blue wire is an Ethernet wire, or Cat6 cable technically, which we custom made to work with this BMS can. So this battery does work with the Cerbo GX. It took me a lot of trial and error trying to figure out how to make it work, but we did make it work. If you're curious in that, there'll probably be a different video dedicated on how you can kind of set that up. But that's how the internal part of this conduit box is connected to, let's just say, the inverter and also the Cerbo GX. So this right here is EG4 wall mount indoor battery, and you've probably seen this battery, but just in case you haven't, here's a quick overview. It's an EG4 branding stamp right here, which you can't see, but it's got 4 of the green bars that kind of tells you the status of fuel gauge of the battery. It has like 2 other LEDs right here for alarm, in case something happened. It'll flash red. Green flashing means it's running and it's working pretty good. As you can see on here, this is also a touch screen. It'll tell you the state that it's in, whether it's discharging or charging, right? The address I have set on here is 1, and right now I have set the CAN protocol communications on here, the P06, which is Victron, okay? That's how we got the BMS communications working. This right here is the protocol you have set if you're using RS485, which you're not using. The reason I keep touching this is I don't want it to turn off. This right here is the voltage. This right here is the amp hour capacity, and this is the amps currently running through the battery, which right now is 0.9 amps. You can go in the settings and, you know, look at other stuff, look at the temperature. I'll change other communication protocols, and also look at the version of the firmware and all that kind of fun stuff. So like I said, this stuff is all here. So this is a really nice battery, especially if you combine it with the conduit box, because everything sits nicely inside the conduit box and can look decently pretty clean. So this right here is a GX Touch 50. It actually connects, it's a hardwired cable permanently installed here using this HDMI cable, and it permanently connects, as you saw earlier, on there with HDMI. It is a touch screen, and I'll try to stand so the glare is minimized here, but it's got this thing called pages, which kind of shows you the pages. You can kind of see like this page right here, or you can go and look at this page that kind of gives you like a system overview, right? So the information is very similar on both pages, but right now you can kind of see that the battery is at 98% capacity. See if we can get that to go away here. Get the screen to minimize, or just minimize. Oh, there it goes. Well, let's go back to pages. Right now, it's the inverter is in status inverting, and you can see the power flowing from the battery to the inverter, and from the inverter to the AC load. So right now there's a 40-watt load on it. It's just a small fan, but also tell you how much is coming out of the battery, which is 47 watts, right? The battery current voltage and the amps currently coming out of it. This red box here is for grid in or AC in, right? So if you had grid connected, there would be, grid power flowing from here, or generator connected, it would just be flowing from here, right? So there's an empty white box here, mainly because I do not have a solar charge controller connected to the system. If there was a solar charge controller connected to the system, it would be here. But currently all the panels that I have are connected to the other system I have, so there's no panels connected to this, but this is where the panel configuration would be, or the status would be, and the little dots flowing is pretty much how the energy is currently flowing inside the system. So this is a really nice screen. It is touch, like I said, and depending on which screen you go to, you can kind of see different things here, right? So it's all the same stuff, just in a different manner. Other thing on here, you can go in here and look at the settings. So if I go in the menu, here's all the devices that are currently connected to the system. You can see right here the EG4 LL battery is connected because I have the comms configured. It's at 98%. Here's the battery status. You can go in here and then also see the metrics or the data from the battery, right? So if I stand well enough, you can kind of cover some of the glare, but it's got state of charge, state of health, battery temperature. It's got details on other stuff going on in here, like lowest cell voltage, high cell voltage, temperature, all kinds of stuff, right? Currently configured number of amp hours, right? So when you get communications working with this battery, it's really nice. If there's any alarms, you can kind of go in here and see the alarms, right? Right now they're all okay, because as you saw, there was no alarms on that battery screen. There was no like red LEDs or anything like that. The device, you can kind of go in here and say yes, where it's connected and it's using CAN bus, right? Firmware version, all kinds of stuff is on here. You can even go to the parameters and look at what the parameters are set to, as the communications kind of went and go ahead and set that up, right? But if you go back to menu, here's all the other devices that are connected. So here's the MultiPlus-II that's connected. It's switch on. You can kind of set this. So if there's a little black triangle at the corner here, it means you can change it, right? So I can go in here, click on, and it'll figure out, you know, do I want to turn it off, charger only, inverter only, whatever, right? This right here is input current limit. So I currently have it set to 9.5, mainly because, as we talked about, the undersized wire right there, right? But if I go back there, you can go back in here. Actually, let's get out of here. And then you can look at the DC voltage, DC current, active AC input, which is, you know, not connected. It's disconnected. The AC line 1 in, obviously not connected, as we just talked about. But the output is connected, and it's doing 120 volts, right? 40 watts, and it's going about 60 hertz. There's all kinds of stuff we can do in here. We can spend, you know, hours in here, but we're not gonna go, you know, look at every single detail. But like I said, we'll talk about the important things, because this is connected to VE bus to this product, and it's using this firmware. Also on here, you can go and do firmware updates on here. You can also go into the settings of this Cerbo GX, which is in here, and you can look for firmware updates, right? That one gives you the firmware updates. You can also install the firmware from, if you're in like a remote area, get on like a USB stick or a micro SD card, put it in there and do updates, right? You can also store backup depending on, you know, what you really want to do. But there's also a section in here for notifications, which tells you, you know, any alarms that comes up, right? Like for instance, I had one on here that said new firmware needs to be installed. I didn't capture in here. I'll see if I can find the recording. I kind of caught it at the end. And it'll tell you, hey, notifications are up there. But that only happens if you go in here and you go to firmware and you do check. So online updates, you go to online updates, you can do check only. You can also do like check and install or check or update, right? I have it to, actually it just went to check and update, but I only want it to check right now, right? I want to be able to control when it gets updated, right? You can also press here to check in case you wanted to check. But as I mentioned, it's got all kinds of stuff in here. I'm not going to go through every setting, but the basic idea is all the devices you have connected on here are going to show up in just device list, the battery, the inverter. Obviously, the Cerbo GX probably won't show up on here because that's pretty much the brains of this operation. But all the other devices, like if I had another MultiPlus or some other stuff connected, it would show up here, or the shunt, right, which I don't have. All right, so let's go take a look at the screen. So I just plugged in the grid or the AC in or mains in, so you can see the red boxes here. Lines power's coming in, about 1,000 watts is coming in from the grid, and part of it is going to the battery, right? So the battery is being charged at roughly 888 watts, 16.8 amps in. And these little dots you see here, I'm not sure if everybody knows this, is pretty much the dots you see on the front of the inverter, right? So on the front of the inverter, it's gonna say charger, and then it's gonna say mains on. That's what this green light is. This yellow, orangish looking light here is the bulk, right? Means it's in bulk charge. There's an absorption section here, which is the third dot, which is not lit. And then the fourth dot right here is the float, right? So the 4 dots here actually are a mirror of what's on the front of the inverter. And these dots here is pretty much what the inverter dots are, right? So there's inverter on, overload, low battery, and temperature. So they replicated pretty much everything you need to be able to see on the inverter on the screen, just in case you had the inverter in a remote place and you were only operating off of this screen, right? So power's coming in from the grid, charging the battery, and charging or powering the loads. You can also go to this page and see pretty much the same thing if you wanted to just read the numbers and didn't really care for the animation. So we're gonna try to do a quick demo of the failover. This right here is connected to your mains 1, right, AC 1 output. And then this lamp right here, which you can barely see that it's on, is connected to the AC output 2. Right, so right now the grid is connected and then it's charging and also powering both of these. So if everything is configured, which is, it really is out of the box, you don't have to do anything. When you unplug the grid, the light number 2, this light should go out while this light should turn on, and it shouldn't even blip. So here we go. Let's go ahead and unplug the grid real quick. Right? Did you see that? I bet you didn't. So that's pretty much the Victron MultiPlus-II in a nutshell. We don't have the entire ecosystem. We don't have the bare minimum. We just have, like, I want to call it maybe the basics, right? You can run the MultiPlus-II without the GX Touch and the Cerbo, right? You could just have this and this, but you really wouldn't have any idea of what's really going on, right? So to incorporate the screen, which is maybe about 200 bucks, and this Cerbo GX maybe about another 200 bucks, so 400 for that, and this 3000 VA is roughly around 1100 or 1200 bucks, right? It's probably somewhere close to about 1500 bucks for just this, all right? So I can see why some people say Victron's gonna, you know, be a little bit more pricey, right? But if you think about, you know, some people equate heftiness, right, to quality. And if you pick this thing up, you're gonna know this thing is pretty hefty. I mean, it's a low frequency transformer based inverter, and it's probably just gonna work for a long time. And you know, there's not really too many things to go wrong with it. Sure, there are things that can go wrong with it, but you know, there's not as many components as like a high frequency inverter, right? So the other thing I hear all the time is they say Victron is going to nickel and dime you, and you may feel like that, right? But it's kind of like an a la carte system. You just pick and choose the components that you want and then you need, and then you buy those things. It's not like I want to buy a kit and it includes like, you know, these 10 things. I'm sure maybe there's some distributors that do sell it that way, right? But it's really more of you pick what you want and you put together your system, right? So there is a benefit to that because, like, instance, if you have an all-in-one system, maybe you need more of only inverter capacity, but you probably need to add like another charge controller or something like that. Or you just need only more charge controller and less inverter, right? But if you're an all-in-one, you kind of have to add maybe multiple of those, whereas in this type of system, modular system, you just add whichever components you need and it really works. And you can, like I said, run it bare bones, but if you want to get online portal connectivity, which we didn't cover, and maybe we'll cover in a later video, but you know, this is getting just too long, is that you need the Cerbo GX, because this is what transmits data to the cloud. If you look at the documentation on the Cerbo GX, they also designed it for internet connections that, you know, have a lot of packet loss, which is really good because a lot of these systems will be installed in places that don't have good access to internet, okay? So with that, I will say with Victron, most people complain about nickel and diming and price, but nobody ever really complains about the support. I haven't had to reach out to support or any of that. They don't complain about, you know, dead on arrival or any of those types of issues. Issues related to things just working seems to be solid. With that being said, this is the system for now. In a later video, we'll probably expand it to a 240 volt system and then set it up with also this battery, mainly because I do think, like I said, it's a perfect combination. And then we can also run 240 volt loads. But for a bare 120 volt load with a 35 amp charger and transfer switch, automatic transfer switch, and all that stuff built in, this is a great deal for a long quality, and you'll probably have it running for years to come. So hopefully this video helped you guys out. If you have any questions, let us know. Otherwise, have a great day, get back to work, and we'll see you guys next time.